I'm welcoming everyone to this case study video presentation for a topic turbo machinery and Stratolance carrier aircraft from Hindustan Aeronautics Limited, Bangalore. Myself, N. Venkatesh, working as an assistant professor in SNS College of Technology from the Department of Aeronautical Engineering. So, these are the contents we will discuss in these videos: the introduction, general specifications, engine, working overview, and launch procedure. Before we go into the topic, what is meant by a turbo machinery? So, turbo machinery in mechanical engineering describes a machine that transfer energy between a rotor and a fluid, including both turbines and compressors. While a turbine transfers energy from a fluid to a rotor, a compressor transfers energy from a rotor to a fluid. These two types of machines are governed by same basic relationship, including Newton's second law of motion and Euler's pump and turbine equation for compressible fluids. Centrifugal pumps are also turbo machines that transfers energy from a rotor to a fluid, usually a liquid, while turbines and compressors usually work with a gas. And that the first turbo machines could be identified as water wheels. Wheels appeared between the 3rd and 1st centuries in modified region. These were used throughout the medieval period and began the first industrial revolution, when steam power started to be used as the first power source driven by the combustion of a fuel rather than renewable natural power sources. This was reciprocating engines, primitive turbines, and conceptual designs for them, such as the smoke jack, appeared intermediately, but the temperatures and pressures required for a practical efficient turbine exceed the manufacturing technology of the time. The first patent for gas turbines were filled in 1791 by John Barber. Practical hydroelectric water turbines and steam turbines did not appear until the 1880s. The first impulse type turbine was created by Karl Skorloff in 1883. This was closely followed by the first practical reaction turbine in 1884, and that since development has skyrocketed from Parsons' early designs producing 0.746 kilowatt to modern nuclear steam turbines producing upwards of 1500 megawatt. Today, steam turbines account for roughly 90% of electrical power generated in the United States. Then the first functioning industrial gas turbines were used in the late 1890s to power street lights. This is the introduction of a turbo machinery aircraft. And this introduction, it's an American space transportation venture developing a New Year launch to orbit system. The first test flights is a 2019 was launched. Commercial launch will be a 2020. The aircraft requires 12,500 feet and 200 feet runway for takeoff and thus leading. This is an American space transportation in first session. And then generally, the classification of the two kind of turbo machines included in practicals are open and closed turbo machines. Open machines such as propellers, windmills, and unstored fans act on an infinite extent of fluid, whereas closed machines operate on finite quantity of fluid as it passes through a housing or cashing. The turbo machines are also categorized according to the type of flow. When the flow is parallel to the axis of rotation, they are called axial flow machines, and when flow is perpendicular to the axis of rotation, they are referred to a radial. There is also third category called mixed flow machines, where both radial and axial flow velocity components are present. Turbo machines may be further classified into two additional categories: those that absorbs energy to increase the fluid pressure in pumps, fans, compressor, and those that produce energy as turbines by expanding flow to lower pressures. Of particular interest are applications which contain pumps, fans, compressor, and turbines. These components are essential in almost all mechanical equipment systems such as power and refrigeration cycles. This is the classification of the fluid machinery in spices and groups. In hydraulic machinery, its a propeller will be a centrifugal pump and turbo pumps are used, and the combination of power and machinery is fluid coupling and clutches and work and pump and turbines. Thermal turbo machinery, compressor, gas turbines, steam turbines will be used. Any device that extracts energy from or impacts energy to continuously moving steam or fluid can be called a turbo machine. Elaborating, a turbo machine is a power or heat generating machine which employs the dynamic motion and action of a rotating element, the rotor. The action of the rotor changes the energy level of the continuously flowing fluid through the machine. Turbines, compressors, and fans are all members of this family of machines. In contrast to positive displacement machines, the majority of turbo machines run at comparatively high speed without any mechanical problems and volumetric efficiency close to 100%. As the energy conversion, turbo machines can be categorized as the basics of the direction of energy conversion. Absorbs power to increase the fluid pressure or head. Examples ducted fans, compressor, and pumps. Produce power by expanding fluid to lower pressure or head. It's a fluid flow. The next one is in the general specification of a aircraft is considered as a aircraft design and the wing and the wingspan and there's a engine. For a aircraft design, the innovative dual fuselage and a high wing design will be launch vehicles to release from the aircraft centerline and below the wing of a much straighter development. On the center wing of the aircraft, the reinforced center wing provides a lift, stability, and pythons that can be support multiple launch vehicles weighing overing 5 lakh slips to 1 to 17.6 kg. The engines of a six Boeing 747 engineers allow for a payload capacity of over 5 lakhs. Wingspan. The wingspan is the largest of any plane ever assembled, stretching longer than American football field, including the span. And these are the engine powered by 6-prod and Whitney turbo engines will be used in the principle of turbo machines. When the path of the flow is wholly or mainly parallel to the axis of rotation, the device is termed an axial flow turbo machine. The radial component of the fluid velocity is negligible. Since there is no change in the direction of the fluid, several axial stages can be used to increase power output. A Kaplan turbine is an example of an axial flow turbine. In this figure, U is a blade velocity, Vf is a flow velocity, V is an absolute velocity, Vr is the relative velocity, and Vw is a tangential or built component of the velocity. So radial flow turbo machines, when the path of the flow is wholly or mainly in a perpendicular to the rotation axis, this device is termed as radial flow turbo machine. Therefore, the changes of radiation between the entry and the exit is finite. The radial turbo machine can be inward or outward flow type depending on the purpose that needs to be served. Outward flow type increases the energy level of the fluid and vice versa. Due to the continuous changes in direction, several radial stages are generally not used. A centrifugal pump is an example of a radial flow turbo machine. It's a mixed flow turbo machine and a Francis turbine. In that action, turbo machines can finally classify in the relative magnitude of the pressure changes that take place across a stage. Impulse turbo machines operated by accelerating and changing the flow direction of fluid through stationary nozzle. The nozzle serves to change the incoming pressure into velocity. The enthalpy of the fluid decreases as the velocity increases. Pressure and enthalpy drop over the rotor blades is minimal velocity will decrease over the rotor. So Newton's second law describes the transfer of energy impulse. Turbo machines do not require a pressure catchment around the rotor since the fluid jet is created by the nozzle prior to reaching the blading on the rotor. A Pelton wheel is an impulse turbine. So reaction turbo machines operating by reacting the flow and fluid through aerofoil shaped rotor and stator blades. The velocity of the fluid through the set of blades increases slightly as with as it passes from rotor to stator, vice versa. So Newton's third law describes the transfer of energy for turbine reactions. A pressure catchment is needed to contain the working fluid. For compressible working fluid, multiple turbine stages are usually used to harness the expanding gas efficiently. Most turbo machines use a combination of impulse and reactions in their design, often with impulse and reaction parts of the same blade. The following dimensionless ratios are often used for the characterization of fluid machines. They allow a comparison of flow machines with different dimensions and boundary conditions. It's a pressure range, flow coefficient, performance numbers, run numbers, and diameter numbers. Is the working overview of turbo machines will be represented in this diagram as cut from an internal session of this session. Here the turbo machines will be any device extract energy from impacts energy to continuously moving steam or fluid can be called turbo machine. Elaborating, a turbo machine is a power of head generating machines which employs the dynamic action of rotating element. The thermal turbo machinery compressible fluid, it uses a compressor, it's a blade and gas turbines, its application in steam turbine and jet engines. In contrast to positive displacement machines type, which are low speed machines based on the mechanical and volumetric efficiency, the majority of the turbo machines run at comparatively higher speeds without any mechanical problems and volumetric efficiency close to 100%. It's an energy conversion. It absorbs power to increase the fluid pressure on the basis of the direction of energy conversion. So produce a power by expanding fluid to a lower pressure or head. It's a fluid flow. Turbo machines can be categorized as a fluid flow, is the axial flow and a coupled plate turbine, and that the device is termed axial flow turbine when the path of the flow is wholly or mainly parallel to the axis of the rotation. So component will be used. A coupled turbine is an example of an axial flow turbine. The velocity angle diagrams for the coupled and radial flow turbine will be measured and used for find displacement and angle locations and kinematic velocity. When the path of through the flow is wholly or mainly in plane perpendicular to the rotation axis, the device is termed as a radial flow turbo machine. This is a manufacturing supply status at the Pratt Whitney International. These are the some link, what are the ranks, what are the manufacturing companies. For example, in 2013 of the year, the number one rank is the CFM International. The engines 1386 and the share is 53% and the backlog engines share percentage is 48. Here is the Air Force and Boeing fleet by engine manufacturer will be given by the company names through the overall count. The turbo machines can finally be classified as on the pressure changes as across the blade changes and impulse turbo machines operated by accelerating changing the flow direction of fluid flow through stationary nozzle, and the nozzle servers changes the incoming pressure into velocity. The enthalpy of the fluid decreases as the velocity increases, and the pressure and the enthalpy drop over the rotor blade is a minimal. Velocity will decrease over the rotor. Here is a Pelton wheel is an impulse design. So reaction turbo machines operate by reacting the flow of a fluid through airfoil shaped rotor and stator blades. The velocity of the fluid through the set of the blades increases slightly as it passes from rotor to stator and vice versa, and the velocity is decreases through the set of the blade.